What's up? I'm Vin, and I'm going to go through this 4th grade math practice test, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first up, we have section 1, the multiple choice questions, and there's 32 questions here. And for question 1, we have which expression shows the number 640,805 written in expanded form. So for this one, we have to know place value. So looking here at this number, if we look at the 6 is in the hundred thousands place. That's why every answer choice starts off with 600,000 plus. And then next we have a 4 in the 10,000s place. So that 4 represents 40,000. So the two answer choices we could eliminate would be A and C, because these two answer choices jump to 4,000 next instead of 40,000. And then notice that we have a 0 in the thousands place. So now we could look to the next non-zero digit, which is an 8. And the 8 over here is in the hundreds place. So this 8 represents 800, which eliminates choice B. And this tells us that choice D is our answer. And we could even see that the next non-zero digit is a 5, and it's in the ones place. So that would complete the expanded form of this number here. If we want to check our answer, let's say we want to check the answer here, choice D, what we could do is we could take the numbers and we could stack them vertically, but we want to make sure that when we write these numbers, like let's say 600,000 and 40,000, we want to make sure that we are lining them up at the correct place value. So if I write it like this would be wrong, because notice that I'm aligning everything to the left. I want to align stuff to the right. So I would put this number over here like this and make sure that I'm lining up the ones place, the tens place, the hundreds, the thousands, and the 10,000s. And then next we have 800, but I would write it over here to make sure I'm lining everything up starting at the right like this. And then I put my 5 in the ones place like this. And now when I add, I just go down the line. I have 0 plus 0 plus 0 plus 5, and that's equal to 5. And then we have 0 plus 0 plus 0 is 0. And then we have 0 plus 0 plus 8 is going to give us 8. And then we have 0 plus 0 is 0. 0 plus 4 is 4, and the 6 just carries down. And notice this gives us 640,805, which matches the number from the beginning. Okay, something like, let's say, choice B. Why is choice B no good? Well, if we were to work this one out, you may just be able to do this math in your head, and you'll say 640,000, so 640,000, and then plus 80 plus 5 gives us 85 at the end. So I put a 0, and then I put my 85. But that math could be a little bit tricky to do in your head. So what you could do is you could take the numbers from choice B and you could set up another addition question like this. Okay, so if you have to, you could go through the answer choices one by one, but it does help to be able to see the place value here. That's how I'm able to do this math in my head. Okay, and if I were to write this all out, you could see if I go through the addition again, I'm just adding 3 zeros and a 5 and I get 5. I add these 2 zeros and 8 to get 8, and then 0 plus 0 gives us 0. We get another 0 plus 0, we get a 0 plus 4, and the 6 carries down. So you see how this does not match the original here. So just make sure that you know the place value. Choice D is our answer. Question 2, there are 2 reticulated pythons at a zoo. The first one is 32,845 millimeters long, and the second one is 32,875 millimeters long. Which symbol should go in the circle to correctly compare the lengths? So for this one, we have to know a few things. We have to know which number is the greater number, and we also have to know what these symbols mean. Okay, so for this, just know that this symbol here means less than. Okay, this is the less than symbol. And the way that I remember this, my teacher told me way back in the day, more than 30 years ago, my teacher told me that the less than symbol looks like an L. Okay, so just imagine you have the letter L and you turn it a little bit on its side like this. It's going to look like this, which matches the less than sign. Okay, so that's why, or how I remember that this one is less than, and then this one here is greater than, and then underneath here we have equals. Okay, so this one is equals, and this one is adding. So if we're comparing these two numbers, we're not going to be adding them, so this one is just out right away. So now let's take a look at the numbers here. So we have these two numbers, and notice that they have a matching 3 in the 10,000s place, and then they have a matching 2 in the thousands place, and then the 8 matches in the hundreds place, and then finally the numbers are different at the end. So when I'm doing this math in my head, I'm just thinking about the first set of digits that are different. So I'm comparing 45 versus 75. And I know 75 is the bigger number. So I could say 45 is less than 75. Okay, so this is the symbol we're going to be using here. We're going to say that 32,845 is less than 32,875. Now, another fun way to remember this is that this symbol here, you could just think of this as Pac-Man. So just see, Pac-Man is a fun video game character, but Pac-Man wants to eat the bigger number. So his mouth is going to face the bigger number. If for some reason we had it the other way around, let's say we had 32,875 on the left and we had 32,845 on the right, then Pac-Man's mouth would be facing this way. He would want to eat the bigger number. And let me just draw that one more time. So the bigger number, if the bigger number is to the left, then his mouth is going to face the left here, and he's going to want to eat the bigger number. Okay, so, but in this case, the bigger number is to the right, so we're going with the less than symbol here. Choice A is our answer. Question 3, a traveling circus had 47,382 visitors this summer. What is 47,382 rounded to the nearest 10,000? So for this question, we have to know the steps for rounding. So what we do is whatever they're telling us to round to, we first identify the number in that place. Okay, so the nearest 10,000 tells us to look at the 10,000s place, which is here at the 4. Okay, first we have the 2 in the ones place, then we have an 8 in the tens place, 3 is in the hundreds place, 7 is in the thousands place, but 4 is in the 10,000s place. Okay, if we were to go one more digit to the left, that would be the 100,000s place. So we're rounding to the nearest 10,000, but what we do is we look to the right, okay? And the number here is a 7. And what you do is you ask yourself, is this number 5 or higher, or is it 4 or less? And notice that 7 is 5 or higher, okay? 7 is 5 or higher. So what this tells us to do, it tells us to round up, okay? And we're going to round up to the next digit. So if we're looking at the 4 in the 10,000s place, we're going to round it up to a 5, which is going to round this whole thing up to 50,000. Okay, so 50,000, choice D, is our answer. But if this doesn't make sense, like if you're just following steps and memorizing here, it's good to look at the concept of what's going on. Okay, so I'm going to draw out a number line, and I'm going to draw in, we have 40,000, and then if I count by 10,000s, the next number would be 50,000. And I'm going to draw here. I'm just going to mark these off. So these are the endpoints here. And I'm going to draw in the middle. The halfway point would be 45,000. Okay, so halfway from 40,000 to 50,000 would be 45,000. So if you think about this number, 47,382, that would be located somewhere over here. Okay, so this is where 47,382 is located. But now you're asking yourself when you're rounding, which number is our number closer to? Is it closer to this number or this number? Is 47,382 closer to 50,000 or 40,000? And I think it's clear here that this number is closer to 50,000. So when we round, we're just bringing the number to the closer number that we're counting by. So if we're rounding to the nearest 10,000, just think of a number line where you're counting by 10,000s and you're asking yourself, which number is my number closer to? And in this case, our number is definitely closer to 50,000. So choice D is definitely correct. Question 4, how many times greater is the value of the digit 7 in 71,324 than the value of the digit 7 in 53,173? So for this one, we have to know place value. The value of 7 in this number is equal to 70,000. If I had to write this number here in expanded form, this would be 70,000 plus we have a 1 in the thousands place, so that'd be plus 1,000, plus a 3 in the hundreds place means 300, and then plus a 2 in the tens means 20, plus a 4 in the ones means plus 4 at the end. Okay, so the value of the digit 7 in the first number is 70,000. And now we move on to the second number here. So if I write this number in expanded form, we have a 5 in the 10,000s place, so that's equal to 50,000. So we have 50,000 plus we have a 3 in the thousands place, so that's 3,000, plus a 1 in the hundreds place, so that's plus 100, plus the 7 is in the tens place, so that would be equal to 70, and then we have plus 3 at the end. So the value of the digit 7 in the second number is equal to 70. So if we want, what we could do is we could rephrase this question. We could answer the question, how many times greater is 70,000 than 70? And to find this, what we could do is we could just divide. We could do 70,000 divided by 70. And this we could write as a fraction. We could say 70,000 divided by 70. And there's a nice trick when you're dividing numbers that have zeros at the end, and this is when you're working with whole numbers, you can cross off the common zeros at the end. If I had something like, let's say 707 divided by 70, I can't cross off these zeros because this 0 is at the end, but this one here is in between whole numbers. Okay, so we could only do this when we have zeros at the end of our whole number. So now this will simplify to, we have 7,000 divided by 7. And for this one, I'll go ahead and do long division. Okay, so I'm going to have 7,000 divided by 7. And now 7 goes into 7 one time. 1 times 7 is 7. We subtract, and we get a remainder of 0. And now we bring down the next 0, and then 0 divided by 7 is equal to 0. So we write our 0 here. 0 times 7 is 0. We subtract 0, and now we bring down the next one here. So we bring down the next 0. 7 goes into 0 0 times. 0 times 7 is 0, and we subtract. And now we have another 0. We bring down the last 0. And then we do 0 divided by 7 is still 0. And we have 0 times 7 is 0. We subtract, and this tells us we have a remainder of 0, which means these two numbers divide evenly. And this tells us that the value of the digit 7 in the first number is 1,000 times greater than the value of the digit 7 in the second number. So choice C is our answer. Question 5, we're doing 4,796 plus 1,485. And for long addition, you want to make sure that you are lining the numbers up by the correct place value. So I'm lining up the ones place, the tens, the hundreds, and the thousands place. So we could start this off by adding the numbers in the ones place. So we're doing 6 plus 5. And when I do this math in my head, what I'm thinking is when I do 6 plus 5 is 11, I'm going to write the 1 in the ones place from this number over here. But then the 1 from the tens place is going to get carried over to the next column here. So I'm going to put that 1 over here. And then I'm doing 1 plus 9 is 10, and 10 plus 8 is 18. So then when I do 18, the 8 goes first, and then I carry the 1 to the next column. And that's just how this process goes. You just carry this on until you complete the addition all the way to the left. So next we're doing 1 plus 7 is 8, and 8 plus 4 is 12. So when I think of 12, I'm thinking of the 2 is showing up first in the ones place, so I write that first, and then I carry the 1 to the next column. And then I go 1 plus 4 is 5, and 5 plus 1 is 6. And we get 6,281, which tells us choice B is our answer. Question 6, we're doing long subtraction, but notice that the numbers are lined up horizontally. So for questions like this, it really helps if you line the numbers up vertically. So we're going to do 7,342 minus 5,786. And for this one, we're going to have to borrow because we can't do 2 minus 6. We have to have our number in the top position be greater than the number in the bottom position, or they could be equal. So what I have to do is I have to borrow from this place over here. So I borrow from the tens, and that would bump the 4 down to a 3. And then I put my 1 in front like this. So now I'm doing 12 minus 6 is equal to 6. And then I continue on. But once again, I have the issue of doing 3 minus 8. I can't do this because 3 is less than 8. So I have to borrow from the next column here, and I turn that 3 into a 2, and I put the 1 over here. And now I'm doing 13 minus 8, which is 5. And then same issue, 2 minus 7 I can't do because 2 is less than 7. So I borrow from the thousands place, I bump the 7 down to a 6, and I carry the 1 over here. And now we're doing 12 minus 7 is 5. And then finally we could do 6 minus 5 is 1. So our solution here is 1,556. Choice B is our answer. Question 7, there are 24 hours in one day. How many hours are there in 128 days? Well, if we think about this, all we have to do here is multiply. If you wanted to, what you could do, but this would take a really, really long time, is you could say, all right, 1 day goes by, and then we have 2 days, and then we have 3 days. And I'm not going to write this all the way to 128, but let's pretend I wrote all the numbers down to 128 days. And I could just make a little table here and say for each day there are 24 hours. Okay, so we have 24 hours in the first day, 24 hours in the second day, 24 hours in the third day, and then finally the last 128th day we have 24 hours. And if I wanted to, I could just sit here and add all of this up. But this would take a really, really, really long time. Okay, but repeated addition is multiplication. So instead of doing 24 plus 24 plus 24 plus itself 128 times, I could just do 128 times 24. Okay, I could also say 24 times 128, but I prefer to write the numbers like this because anytime I do long multiplication, I like to put the bigger number on top, the one that has more digits. And now we multiply it. We have 4 times 8 is 32. But the thought process here, when we think 32, the 2 should go first and we carry the 3 to the next column. And now we're doing 4 times 2 is 8, and then 8 plus 3 is 11. But when we think of 11, the 1 goes down and then the next one carries to the next column. And then we're doing 4 times 1 is 4, but then 4 plus 1 is equal to 5. Okay, so we get 512. But now since we're done multiplying from the ones place, we're going to start multiplying from the tens place, but we have to put a 0 here as a placeholder. Okay, since we're starting from the tens. And for this, now we're doing 2 times 8 is equal to 16. But the 6 we're going to write first, and I'll cross out the numbers from before, and let me change colors here when we write in this top space over here. So we're doing 2 times 8 is 16. We write the 6 first, and then we carry the 1, but I'm going to carry the 1 in a different color. So we're going to put that 1 over here. And now next, we have 2 times 2 is 4, and 4 plus 1 is equal to 5. Okay, and we don't have to carry anything over because 5 is a single digit number. And then finally, we do 2 times 1 is 2, and now we could add everything up. Okay, so we're going to do 2 plus 0 is 2, 1 plus 6 is 7, 5 plus 5 is 10, so we have a 0 and we carry the 1, and then 1 plus 2 is equal to 3, so there are 3,072 hours in 128 days. So choice C is our answer. Question 8, 3,418 divided by 4 equals, and for this one we're going to do long division. So we have 3,418 and we are dividing by 4. And what we ask ourselves is how many times does 4 go into 3? But 4 does not go into 3 nicely. Okay, if you think about the times tables for 4, if I just start listing the multiples of 4, I could say 4 times 1 equals 4, 4 times 2 equals 8, and notice that these numbers here go too far, okay? So we can't say 3 divided by 4, so we're going to have to look at the next digit with the 3, okay? So now we do 34 divided by 4, and the closest we could get is 4 times 8, okay? If we do 4 times 8, this is equal to 32. If we did 4 times 9, just add 4 more, you would have 36, which goes too far, okay? So we could get as close as 4 times 8. So we're going to put our 8 here, and then 8 times 4 is 32, and we subtract. 34 minus 32 is equal to 2. We carry down the 1. And now we just have to think of the multiples of 4 yet again. And this one, I'm thinking of 4 times 5 is 20. And if I went one more, 4 times 6 is 24, which goes too far. So we could get as close as 4 times 5. And then we have 5 times 4 is 20. We subtract, and we have a remainder of 1. And one thing I want to point out, notice all of the answer choices start off with 8 and 5. So if you ever get stuck in the multiple choice, sometimes the answer choices give you a clue as to what you should be writing next. Okay, but let's just say we didn't see the answer choices at all, and we want to get there by just the thought process. Then this is the way to think your way through this question. So next, I'll bring down this 18 here. And if we look at this number, so I'll just continue, or I'll just switch up this list here. How about I get rid of these numbers here? When I look at 18 and I'm thinking in terms of 4, 4 times 4 is equal to 16, and 4 times 5 is equal to 20. So I could get as close as 4 times 4. So I put a 4 here, and then 4 times 4 is 16. We subtract, and we have a remainder of 2. Okay, but if I say 854 remainder 2, notice that I have two answers with an 854. One of them has no decimal after. Okay, it's just like imagine a 0.0 here. And this one has point something other than 0. So that's how I know right away it's going to be choice A. But let's think about this. 854 remainder 2 is the same thing, since we divided by 4, as saying 854 remainder 2, but then we're over 4 like this. And then you should know that 2 over 4 we could reduce by dividing the top and bottom, or the numerator and denominator, by the greatest common factor, which is 2. And if I do 2 divided by 2, I get 1. If I do 4 divided by 2, I get 2. So I could call this 854 and 1/2. Okay, and that's why it's going to be choice A. If you're not seeing the connection here between 854 and 1/2 versus 854.5, well then just know that I could take something like 1/2 and I could multiply it by 5 over 5. And this would give us 5 over 10, and 5/10 is the same thing as 0.5. Okay, so then I could just swap out that 1/2 and say 854.5 like this. So choice A, once again, is our answer. Question 9, the table below shows how each input number is matched with an output number. And we want to know which rule describes how to get from the input number to the output number. So for this one, we just have to look at the numbers on the left and see how do they go to the numbers on the right. We're going from the input to the output. So choice A is very tempting because we can say that 6 plus 12 is equal to 18. But choosing choice A is a very dangerous bear trap, okay? A is no good because if you were to try this rule for the second value here, 7 plus 12, if we add these two, we get 19, which does not match the number to the right here. So this one is not going to work. Choice B is no good because this is just saying how do we get from one input to the next input. If we just go plus 1, that just brings us from 6 to 7, and then plus 1 brings us to 8. So B is out because we're going from the input to the output. And then the next one here, choice C, is the one we want, okay? Because if we do times 3, 6 times 3 is equal to 18. If we do 7 times 3, same rule, 7 times 3 gives us 21, so that would send 7 to 21. And if I do that rule again for 8, 8 times 3 is equal to 24. So that rule will get all of the input values to the corresponding output values. So choice C is our answer. Choice D is no good. Choice D would be good if we want to go from the output back to the input, but we're going from the input to the output. Okay, so for this one, we're not going to go with choice D. Choice C is our answer. Question 10, it's field day at school and there are 3 activity stations set up for students. Here's how many kids can be at each station. The tug of war station can fit 150 students. The obstacle course station fits 30 fewer students than the tug of war station. And the water balloon station fits 2 times as many students as the obstacle course station. How many students can take part in field day altogether? So for this one, we just have to organize everything and go piece by piece. So tug of war, I'm just going to write over here like this. So we have tug of war can fit 150 students. So I'm just going to write 150 like this. And then next we have the obstacle course station. Okay, so the obstacle course station fits 30 fewer students than the tug of war station. So 30 fewer tells us to subtract 30. So that would be 150 minus 30. Okay, so 30 fewer says do minus 30. And now 0 minus 0 is 0. 5 minus 3 is 2. So this tells us that 120 people can go to the obstacle course station. And then finally, the water balloon station, they tell us that this fits 2 times as many students as the obstacle course station. So there's 120 people that could fit at the obstacle course station. So we just have to multiply that by 2 because we're hearing 2 times as many. Okay, so times 2. And now we just multiply this out. We have 2 times 0 is 0, 2 times 2 is 4, and 2 times 1 is 2. So this tells us 240 people could fit at the water balloon station. But what they're asking here is how many students can take part in field day all together. Okay, so this will tell us to add everything up. We're going to go 150 plus 120 plus 240. So we add all three of these, and now we have 0 plus 0 plus 0 is 0. We have 5 plus 2 is 7. 7 plus 4 is 11. So we write our 1 and we carry the 1 up here. Now we have 1 plus 1 is 2, plus 1 is 3, plus 2 is 5. So this tells us that 510 students can take part in field day altogether. Choice D is our answer. Question 11. At Bear Creek Elementary, the assistant principal ordered 6 boxes of new crayons for each third grade classroom. There are 5 third grade classrooms and each box costs $4. Which equation shows T, the total amount the school spent on crayons? So for this one, we have to think about what's happening. So the idea for this question is thinking about how do these numbers all interact. So the assistant principal orders 6 boxes of new crayons for each third grade classroom, and there are 5 third grade classrooms. So for one, we could just see, let's say I draw out 5. So I have 1, 2, 3, 4, 5 like this. Okay, so let's say these represent the 5 classrooms. Each classroom is going to get 6 boxes of new crayons. Okay, so that's going to be 6s going all the way through like this. Okay, so then let's think about how many boxes of crayons is this? Well, if there's 5 classes and each one is getting 6 boxes of new crayons, then there's going to be 6 times 5, or we could say 30 boxes of crayons that are ordered. Okay, so the assistant principal is going to get 30 boxes of crayons. Okay, so let's think about that. We have 30 boxes of crayons. But now let's think about what are we doing next? Well, each box costs $4. So if the assistant principal is getting 30 boxes, that would be 30 then times 4, and that would tell us how much money the school is going to spend on crayons. And if we do 30 times 4, that's going to give us 120. Okay, the math that I'm doing in my head is I just think 3 times 4. So 3 times 4 is equal to 12. So when I do 30 times 4 in my head, I just add a 0 to this one above. So that's where I'm getting 120 from so quickly. Okay, so this tells us the assistant principal is going to spend $120. But now let's just think about what actually happened here. Well, we did 6 times 5. And another thing to point out here is that something like 6 times 5, I could flip the order here and say this is equal to 5 times 6. Okay, so I'm looking here and say, all right, we did 6 times 5, or 5 is showing up first in these answer choices. So I could also say I did 5 times 6, and then the result I got there, I multiplied by 4. Okay, so really what happened here was we did 5 times 6, and then that answer, 30, we multiplied by 4. So we did 5 times 6 times 4, which tells us that the total amount T is equal to 5 times 6 times 4, which is modeled by choice B. Okay, choice A is no good because if you just do 6 times 4, that would be if only one class got boxes of crayons, okay? And they got 6 boxes for one class and each box costs $4. That's ignoring the fact that there are 5 third grade classrooms. So that's why A is no good. C is no good because you wouldn't add all of these numbers up, okay? That wouldn't work here. We could even see that if we just look at the 5 classes and each one's getting 6 boxes of crayons, it's pretty obvious if you add 6 plus 6 plus 6 plus 6 plus 6, you're also going to get 30, but then you have to account for the fact that each box costs $4, okay? So this answer choice is no good, and just 5 times 4 is no good because that would just be saying like, okay, there's 5 classrooms, and each classroom, they're going to spend $4 on each one. It's ignoring the fact that each class is getting 6 boxes of crayons. Okay, so D is out, definitely choice B. Question 12, which number is represented by M? And we have 8 times M equals 144. So for a question like this, it helps to know the relationship between multiplication and division. Okay, multiplication and division are opposites. So if I think about something easier, like let's say we do 6 times 4. 6 times 4 is equal to 24. But what I'm allowed to say with this, I could say that 24 divided by, let's say, 4 is equal to 6. Okay, if 6 times 4 equals 24, then 24 divided by 4 is equal to 6. I could also say 24 divided by 6 is equal to 4. Okay, so when you know a nice multiplication fact like this, 6 times 4 is 24, you could write 2 division facts based off that. So that's where my head goes for a question like this. If 8 times M equals 144, then we could say m is equal to 144 divided by 8. And now all we have to do is the long division. Okay, so I'm going to set up over here 144 divided by 8. And we could say, if I list the multiples of 8, so we have 8, and then we do 8 plus 8 is 16, then we get 24, then we get 32, 40, and so on. That 8 goes into 14, we could get as close as 8 times 1. Okay, we can't go to 8 times 2 because 16 would be too big. But now we do 1 times 8 is 8, and we subtract. 14 minus 8 is equal to 6, and now we bring down the next one here. We bring down the 4. If I were to continue the list, so we have 48, and then we have 56, and then we have 64. This would tell us 64 divided by 8 divides nicely, and we get 8. Okay, so 64 divided by 8 is 8. If we do 8 times 8, we get 64, and this tells us we have no remainder. Okay, so 144 divided by 8 is equal to 18. So choice C is our answer. Question 13, which list shows only fractions that are greater than 1/2? So for this question, we could do this a few ways, but one way would be to draw this out. 1/2, if you draw out 1/2, you could think of a circle and you cut it right down the middle like this. And 1/2 would be if we just shade in one of these two equal pieces. So that's what 1/2 looks like. And we're looking for the list that shows only fractions that are greater than 1/2. So choice A is out, and the reason why A is out is because of that first fraction, 1/4. 1/4, if you draw a circle and cut it into 4 equal pieces like this, 1/4 is less than 1/2. Okay, you can see 1/4 is less than 1/2. And you can see visually because more is shaded with this one than is shaded with this one. Okay, so A is out. Now next, choice B is out because of 2/5. 2/5, this could be tricky to draw, but what we could do is we can make common denominators between 2/5 and 1/2. And the least common multiple of 2 and 5 of the denominators is 10. So the common denominator I want is 10. So to make a denominator of 10, I would multiply 5 times 2. But if I multiply the denominator by 2, I have to multiply the numerator by 2 to make an equivalent fraction. So now 2 times 2 is 4, over 5 times 2 is 10. And this tells us that 2/5 is equal to 4/10. But 1/2, if I want to turn this into denominator 10, I take 1/2 and I multiply the top and bottom by 5. And now I have 1 times 5 is 5, over 2 times 5 is 10. And we could see that 1/2 has a numerator of 5, 2/5 has a numerator of 4. So this tells us that 4/10, which is equal to 2/5, is less than 5/10, which is equal to 1/2. Okay, so this once again tells us that 2/5 is less than 1/2. But we need a list that shows fractions that are, well, only fractions that are greater than 1/2. So that's why this one is out. Choice C is in fact our answer. And the giveaway here is we could draw some of these out, or we could just look at this and compare the fraction to 1/2. So 1/2, if I want a denominator of 12, I multiply top and bottom by 6. And this would give us 6/12. But notice here we have 7/12. 7 is greater than 6, so this tells us 7 over 12 is greater than 1/2. Okay, a little shortcut, what I do is I ask myself, is the numerator more than, so is the numerator more than half the denominator? Okay, that's the math that I'm doing in my head if you want to go through this quickly. Okay, so you can see half of the denominator is 6, and 7 is definitely more than that. So that's how I know this one is good. This one would be tricky to do. Half of the denominator is half of 3, which is 1.5, and 2 is definitely more than 1.5. Half of 4 is 2, and 3 is definitely more than that. And I could say half of 6 is 3, and 5 is more than 3. So that's how I know, doing the math in my head, that choice C is in fact our answer. Okay, but I could draw these out. I could turn 1/2 and these fractions into fractions with common denominators. There's a lot of strategies we could use. Okay, but now for the last answer choice, why is this one no good? Well, the first fraction, 7 over 16, is no good because if we look at 1/2 and we do times 8/8, this tells us 1/2 is equal to 8/16, and 7/16 is definitely less than 8/16. But once again, we were looking for the list that shows only fractions that are greater than 1/2. So D is out, definitely choice C. Question 14, the models below are shaded to represent two different fractions. What is the difference of the fractions represented by the shaded parts of the models? So for this one, what we could do is we could express these fraction models in numerical form. So let's count this out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 total pieces. So our denominator would be 9 for both of these. But for the first fraction, we have 1, 2, 3, 4, 5, 6, 7 pieces that are shaded. Okay, so 7 out of 9 are shaded. I'll make this a little bit neater. So we have 7/9 for the first fraction. But now the second fraction has 1, 2, 3, 4 pieces shaded out of 9. So we have 7/9 and 4/9. And we're looking for the difference. And this word in math tells us to subtract. So we're going to do 7/9 minus 4/9. And when you subtract fractions, the most important thing to look for is that you have common denominators. And notice that we have a 9 on bottom for both of these fractions. And what that allows us to do is we could just go ahead and subtract these. So we could combine these fractions into a single fraction with a denominator of 9. And all we have to do is 7 minus 4 in the numerator. And then 7 minus 4 equals 3. And we get 3/9. And then we look to the answer key and we're like, oh no, my answer is not there. And that's because we're going to have to reduce this fraction. The numerator and denominator are both divisible by 3. So we could divide the top and bottom by 3, and that will reduce this fraction for us. So now we could say our final answer here, 3 divided by 3 is 1. 9 divided by 3 is 3. So our final answer is 1/3. Choice B is our answer. Question 15, point W is 1.4 units from 0. Which number line best models the location of point W? So for this one, I like to think about the number line, but I want to count by 5s. And the reason I'm going to do that is so that we could see the connection here with how we fill out the missing numbers. So if I start at 0 and I start counting by 5s, I get 5, 10, 15, 20. But now if you notice here, see how we have 0, 1, 2? Just imagine here that these numbers pair up, that we have 0 pairs up with this, 1 pairs up with 10, and then 2 is going to pair up with 20. Okay, so then when you think about what are the in-between numbers, I'm not going to say 5, I'm going to say 0.5. Okay, so this is the connection here between the counting by 5 number line and the counting by 0.5s or counting by 1/2. Okay, so then between 1 and 2, I'm not going to say 15, I'm going to say 1.5. So when we're looking for a nice location for point W, and point W is 1.4 units away from 0, choice A right away looks good, because notice that point W is slightly less than 1.5, okay? And 1.4 is slightly less than 1.5. You could think if I drew this number over here, I would call this 14. But now I just throw a decimal in the middle of these two numbers like this, and that shows how 1.4 is slightly to the left of 1.5. The other answer choices are no good, because if we look here, this would be 0.5 again, but W would be between 0.5 and 1. So 1.4 is just not possible because 1.4 is greater than 1. Okay, so B is out. And then this one is no good over here, choice C, because 1.5 is here. So this would tell us that W would be greater than 1.5. But 1.4 is not greater than 1.5, so C is out. And then finally for this one, we have 1.5 over here. But once again, this is no good because we need to look for a good location for W. W has to be 1.4 units away. But see how this is too far? This is really, really close to 2. So D is out, definitely choice A. Question 16, Hank ate 2/3 of his candy bar at lunch, then ate 1/4 of the same candy bar after recess. How much of the candy bar is left? So for this one, we're starting off here with Hank has one whole candy bar and he ate 2/3 of the candy bar. So that means we're going to subtract out 2/3. And when we subtract like this, we need common denominators. And just know a whole number like 1, we could write 1 as 1/1. Okay, and then I leave a space. and we're subtracting 2/3. But the only way I'm allowed to subtract fractions is when I have common denominators. So I'm going to multiply this first fraction here by 3/3. And now we could say over here, this is equal to, we have 1 times 3 is 3, over 1 times 3 is 3, and we're subtracting 2/3. And then from here, we're just doing 3 minus 2/3. So now we get 3 minus 2 is 1. So 1/3 of the candy bar is left. But then in the next part of the question, they tell us that Hank ate 1/4 of the same candy bar after recess. So from here, what we're going to do is we're going to take 1/3 and we're going to subtract 1/4. So here, the thought process is least common multiple. So if we start counting by 3s, we get 3, 6, 9, 12. If we start counting by 4s, we get 4, 8, 12. The least common multiple of 3 and 4 is 12. So that's the denominator I want. So I'm going to go times 4/4. And for this one, I'm going to do times 3/3. And now we work this out. 4 times 1 is 4. Over 4 times 3 is 12. And then minus 1 times 3 is 3. Over 4 times 3 is 12. And now we subtract. 4 minus 3 is 1 over 12. So 1/12 of the candy bar is left. So choice D is our answer. Question 17, angle E is shown on the protractor below. And we want to know what is the measure of angle E in degrees. So for this one, this is a little bit tricky because the rays that are building up this angle, one of them is not facing to the right or left. Notice that this angle is in the middle of the protractor in a way. Okay, in questions where the angle is going this way, like let's say it starts here and it ends here, then all we have to do is just look at the number that it makes contact with. If we have an obtuse angle, we're going to look at the bigger number here. We're not going to go with 50. We're going to go with 130 in a case like this. But in this question, things are a little bit tricky because the angle is in the middle. So here we just have to think very carefully. So what we have is this first ray is making contact with the 30 and the 150 over here. Okay, and then the next ray is making contact with the 140 and the 40. So what's going on here is we're going from this number here, we're going from 30 all the way to 140. So if we want to find out what angle goes from 30 to 140, all we have to do here is subtract. Okay, we are going to subtract. So we could do 140 minus 30, and I will write in the units here too. This is 140 degrees minus 30 degrees. And that gives us, we have 0 minus 0 is 0, 4 minus 3 is 1, and the 1 just carries down. We get 110 degrees. Now, let's say you would rather use the other numbers. You would rather say, okay, I'm going from 40 to 150, like this. You could also do 150 minus 40, and this also gives you 110. And I'll just throw in the degrees for all of this. So either way here, we're going to get choice B, 110 degrees. Question 18, consider the number line below. Between which two numbers is 2/3 located? So this question could get a little bit tricky, but what we could do is find the least common multiple of all the denominators involved. And notice that we have a denominator of 4, 2, and 3. So what I'm thinking about here, the math that I'm doing in my head, is I'm thinking about the least common multiple of those numbers. So if I start counting by 2s, we get 2, 4, 6, 8, 10, 12, 14, and the list goes on. And if I start counting by 3s, so this denominator 3, I have 3, 6, 9, then I have 12, 15, and this list goes on. And if I count by 4s, I have 4, 8, 12, 16, and so on. So the least common multiple of all of these is 12. Okay, so this is the denominator that I want. So when I look at this, I could say, all right, 1/4, I go times 3/3, and that'll turn this fraction 1/4 into an equivalent fraction of 1 times 3 is 3 over 4 times 3 is 12. So I could also call this number over here, this is 3/12. And now I just repeat this process. So for 1/2, I convert this fraction into a denominator of 12, and I go times 6 times 6, and that gives us 6/12. Okay, so we have 3/12 Then we have 6/12. And then the next number with a denominator of 12, I have 3/4. And I want a denominator of 12, I'm going to multiply 4 times 3. But if I multiply the bottom, the denominator by 3, I have to do the same thing on top to the numerator. So we have 3 times 3 on top is 9, over 4 times 3 is 12. Okay, so we get 9/12 is over here. And now I look at this and we have 2/3. Okay, that's the number we want to see between which two numbers is 2/3 located. So 2/3, if I multiply by 4/4, that's going to give us a denominator of 12. 2 times 4 is 8, and 3 times 4 is 12. So let's think about this. 8/12. Between which two fractions is 8/12? Well, it would have to be between these two over here. It would have to be between 6/12 and 9/12 because all of our fractions now have the same denominator. So now we just have to ask ourselves, 8 is between which two numerators? 8 is between 6 and 9. So 8/12, or I could say 2/3, is going to be located between these two numbers here. Okay, so it's going to be somewhere in this space over here. Not necessarily in the middle, but it's going to be between 1/2 and 3/4. Okay, so that's how I know choice C is our answer. Question 19, Hank solved the division problem below. Which expression could be used to check Hank's answer? And we have 2,176 divided by 3 equals 725 remainder 1. So for this one, what we could do is we could think about something easier. Okay, so let's think about something like, let's say I do 10 divided by 3. Okay, 10 divided by 3 is something that's much nicer. Okay, 10 divided by 3, we're dealing with smaller numbers. And we say 3 goes into 10 3 times. 3 times 3 is 9. We subtract, and we get a remainder of 1. Okay, so we have remainder 1. And for this, what we could say from here is to check our work, we would do 3 times 3. Okay, we would do 3 times 3 is 9, but then plus the remainder 1 gives us 10. Okay, so if you want to check your work to a long division problem, what you do is you would multiply. You would do the quotient here, 725, times 3, but then you add the remainder. Okay, so you do, once again, the quotient times the divisor, and then plus the remainder. And if you forget, like, oh no, what should I do? You could always run through an easier question first. Okay, 10 divided by 3 is much easier to work with because the numbers are smaller. Okay, and this is a great skill for math when you explore mathematically, where you look for a pattern or a trend, and then you transfer that to a different case. Okay, so if you forget something in math, you could always explore and look for the trend and then bring that trend back to the current question. Okay, so we would do 725 times 3 plus 1, and that would give us 2,176. So choice A would be our answer. If we had to, we could actually go through the multiplication here. We could do 725 times 3, and we have 3 times 5 is 15, carry the 1, 3 times 2 is 6, plus 1 is 7, and then 3 times 7 is 21. And notice how we have 2,175, and if we do 2,175 and we add the remainder 1, this gives us 2,176, which is the original thing we are dividing into. Okay, so that's how I know choice A is definitely good. And you could check all the answer choices here, but these are going to be no good. Okay, they're all going to cancel out. If you want to think about it conceptually, well, for this one, we wouldn't multiply 725 by the remainder. We would multiply by the divisor and then add the remainder. So B is out. And also here, the opposite of multiplication is division, and the opposite of division is multiplication. So we wouldn't be adding to our quotient here. Okay, to go from the quotient back, we would be multiplying. So that's how I know choices C and D are out right away, because once again, we would have to multiply first and then add the remainder. So definitely choice A. Question 20, the perimeter of a square zoo habitat for Mangalitsa pigs is 144 feet. What is the length in feet of each side of the habitat? So for this one, we should see here that we have a square zoo habitat for these pigs. So I'm just going to draw out a square. And what we're told here is the perimeter of this square is 144 feet. So we should know that the perimeter is the distance going all the way around a shape. Okay, so that would be if we took the side length of each side of the square and added them all up, we would get 144 feet. Okay, so the perimeter is 144 feet. Well, let's think about how do we find the perimeter of a square? Well, a square has the nice property that all four sides are equal in measure. A square also has four right angles, but all four sides are equal in measure. So if I call the side lengths, let's say S, then if I were to add all of these up, all of these sides would equal up to 144. Well, since all four of them are the same, I could also say that 4 times the length of side S is equal to the perimeter, which is 144 feet. But I'm just going to write in the numbers like this. And then from here, remember what we said before, the relationship between multiplication and division, that they are opposites. When I say something like, let's say I go with 6 times 4 equals 24. I could go right from this and say that 24 divided by 4 is equal to 6. I could also say that 24 divided by 6 is equal to 4. So anytime you write out a multiplication fact, you are allowed to go backwards and say a division fact. So if 4 times S equals 144, then this tells us that S is equal to 144 divided by 4. And for this one, I'm just going to go ahead and do long division. And I'll do it in this space over here. So we're doing 144 divided by 4. And we could say that 4 goes into 14 3 times. 3 times 4 is 12. So we subtract. We get a remainder of 2. We carry down the 4. And now we do 24 divided by 4 is 6. And then 6 times 4 is 24. So this divides nicely. Okay, this divides evenly. We could say that S is equal to 36. Now, one extra detail here is just something fun. Anytime you're dividing by 4, and let's say you want to do that math in your head, if you have to divide something by 4 and you want to do the math in your head, you could divide the number by 2 and you divide it by 2 twice. So I could do 144 divided by 2 is 72, and then I could do 72 divided by 2 is 36. So that's just a mental math shortcut you could use to get there. But if this is a test, it's probably a good idea to show the long division like this, just so you're 100% safe. Choice B is our answer. Question 21, what number would complete the pattern? And we have 20, 27, we have a blank, and then we have 41 and 48. Well, the first thing that jumps out is that this list is increasing. The numbers are going up. And what we could do is we could see what number are we adding to get from the first number to the second number. So to find out the mystery number here, you could just do that math in your head and notice that the number being added is 7. Okay, so we're doing plus 7. If that math is a little tricky to do in your head, then what you could do is you could always subtract like this. So you could do 27 minus 20, and you do 7 minus 0 is 7. 2 minus 2 is 0, so we just say the difference is 7. And then that would tell us what we're adding to get from one number to the next. And just to double check that this pattern is valid for the rest of the list, we could do 41 plus 7 on the side and see what that gets us. So 7 plus 1 is 8, and then the 4 just carries down. So it makes sense here that the plus 7 is the pattern because it gets us from the first number to the second number, and it gets us from the fourth number to the fifth number. So to find the mystery number, what we're going to do is we're going to add 7 to 27. So if we do 27 plus 7, we do 7 plus 7 is 14. So we have a 4, we carry the 1, and then 1 plus 2 is 3. So the mystery number here has to be 34. Okay, so choice B is our answer. Question 22, Jasmine started her piano lesson at 3:45 p.m. The lesson lasted 1 hour and 35 minutes. What time did the lesson end? So for this question, I'm going to draw out a clock. Okay, so there's the clock. And in the top spot here is 12. And then we have 1, 2, 3 is to the right. And then we have 4, 5, 6 is at the bottom. 7, 8. And then 9 is to the left. And then we have 10, 11, and it brings us back to 12 when we go one more. Okay, and it keeps going around and around like this. And on a clock, it's helpful to know that 1 hour is equal to 60 minutes. And every time we go forward one number, we're counting 5 minutes. And that should make sense because 12 times 5 is equal to 60. So every time we make one full lap here, we're going 60 minutes or 1 hour. So here, when Jasmine starts her piano lesson at 3:45, what I'm visualizing here is, here's the clock and the minute hand. Let me draw that a little neater. The minute hand is facing 9. Okay, so this is the minute hand. And then the hour hand is going to be facing between 3 and 4. Okay, yes, it is 3:45 p.m., but with a clock, as the minute hand goes around, the hour hand moves slowly to the next hour. Okay, so this is the hour hand, and this is the minute hand at 3:45 p.m. But in this question, they're telling us that it's 3:45 and the lesson lasted 1 hour and 35 minutes. But what I'm going to do is I'm going to break this into pieces. Okay, so the 1 hour and 35 minutes, I'm going to break this into 3 pieces. First, I'm going to add 1 hour. So I'm going to go plus 1 hour. Well, this one shouldn't be too bad to do because when 1 hour goes by exactly, this is the hour spot and this is the minute spot. So when we do plus 1 hour, it's just going to add 1 to the hour, and this is going to bring us to 4:45. Okay, so this would be 4:45. And all that would do here, so if I just get this one out, so 4:45 would then bring us to the hour hand is facing between 4 and 5. Okay, so it's just aiming at this spot over here. So next, we added the 1 hour, we have to add 35 minutes. But the problem is, when we do 45 plus 35, so this is, the thought process for this question, 45 plus 35 is going to be greater than 60. Okay, 5 plus 5 is 10, we carry the 1, and that would give us 80 minutes. Okay, but we can't say that it's going to be 480. Okay, 4:59 is the last minute of the hour, and then 4:60 would bring us to 5 o'clock. So then how do we deal with this when this happens? Well, what I like to do is I like to think about how much time is there in minutes to the next hour. So at 4:45, notice that we have to go 5, 10, 15 minutes to get to 12, okay? Because we're 3 away, but every one we jump is 5 minutes. So we're going 5, 10, 15 minutes. So what I would do is I would break 35 into 2 pieces. One of the pieces I want to be 15, and then the other piece is going to be the difference. 35 minus 15 is 20. So I'm going to go plus 15, then plus 20. So I'm going to add plus 15 minutes. And once again, if 15 minutes goes by, this brings us to the next hour. So the next hour after 4 is 5. It's going to be exactly 5 o'clock. Okay, but we just added 15 minutes. So now we just have to add another 20 minutes. So plus 20 minutes. Now this math is much easier to do. If we add 20 minutes, see how it's going to be 5:20. Okay, so it's going to be 5:20 when the lesson ends. Choice C is our answer. Question 23, a bottle contains 35 over 100 liters of juice. Which decimal shows how much juice is in the bottle? So for this question, we should know that 35 over 100 is 35 hundredths. And as a decimal, that's 0.35. Okay, so for this one, choice B is our answer. Now, for the other answer choices, why are they no good? Well, 3.5 is actually equal to 35 divided by 10. Okay, so that's why this one is just not our answer. So if it was, once again, 35 divided by 10, then we would wind up with 3.5. So that's why that one is no good. Choice C is a close answer, but the problem with choice C is choice C would be 35 over 1,000. Okay, so 35 thousandths, we would have to go out 3 places. So we would have to put a placeholder here with a 0 and then put our 3.5. If we wanted 3.5 to show up first like this, then we could say 350 over 1,000. This would be equal to 0.350. Okay, but that's not the case here. So choice C is out. And then 35.0 is just equal to 35 divided by 1. Okay, so 35 divided by 1 is equal to 35, but we could write any number, any whole number as that number 0.0. Okay, so I could say 35 like this, 0.0, and this is the same. I could say something like even, let's say 5 is equal to 5.0. So that's why this answer choice is, or this fraction is not matching up with this answer choice here. So choice B is definitely our answer. Question 24, which list shows the fractions in order from least to greatest? So for this one, there's a few ways we could go forward with this, but visualizing the fractions could help you eliminate a few of the answer choices. So if we're going from least to greatest, that means we want the fractions just to be getting bigger. Okay, least to greatest means the fractions increase or the fractions get bigger. Okay, so this is how I interpret this. Sometimes in math, you have to be able to say the question in easier language so that you know what to look for. So 1/2 means if I have, let's say, a pizza, that I ate this much. 1/4 means if I have a pizza, I ate this much, 1 out of 4 slices. And you could see that this much on the left is more than this much on the right. So this is not the fractions getting bigger happening here. So choice A is out because 1/2 is greater than 1/4. And now we look at this one. Choice B looks good in the beginning, but let's see. So 1/4 is a fraction like this. Okay, so a pizza and we eat 1 out of 4 slices. And then 1/2 is definitely an increase. And then we have 2/3. So just imagine I'm making, a peace sign here like this. So there's the peace sign. Let me make it a little bit neater. So the peace sign, and that's to make 3 equal pieces. If I eat 2/3, then I'm eating this much. And then 3/4 would be like this. Okay, so it's looking like this list is going in order from least to greatest, but the confusion might be with the last two. It's like, wait a minute, I'm not convinced that this one here, let's say, is smaller than this one. How do we know 2/3 is not greater than 3/4? Well, if we're just confused on the last two fractions, what we could do to make this simpler is when we compare these two, we could find common denominators. Okay, so if you think about 3 and 4, the two denominators, and we look for the least common multiple, here are the multiples of 3. So I'm just going to list out a few of them. And then for 4, these are the multiples of 4, and you can see 12 is the least one they have in common. Okay, so now I'm just going to multiply this one by 4/4, and I'm going to multiply this fraction by 3/3. And we get 8/12 on the left, and on the right, we get 3 times 3 is 9/12. So when you look at this, see how 9 is the greater numerator than 8. This tells us that the original fraction here, 3/4, is greater than 2/3. So this list is in the correct order. Now, why is the next answer choice no good? Just so we're safe here and we know that our answer is 100% good, is if we look 3/4, so I'm looking at this fraction here, shows up first, but then later on in the list, 1/4 shows up, which is definitely smaller than 3/4. So this answer choice is out. And then here, notice we're going from 1/2 to 1/4. And 1/2 is this much, 1/4 is less. So that's a decrease. That's not the fractions getting bigger. So D is out. Choice B is definitely our answer. Question 25. Hank's mom served him 2.5 cups of steamed carrots for dinner. He fed 3/4 of a cup to his dog, who happily gobbled them up. How many cups of carrots does Hank still have to eat? So for this one, we're looking at Hank's plate, and he has 2.5 cups of carrots to eat. But then he's sneaking some of these carrots to his dog. Okay, so he fed 3/4 of a cup to his dog. So if he's feeding them to his dog, that means they're being subtracted. So we're going to do 2.5 minus 3/4. And for this one, we are subtracting a fraction from a mixed number. So one way we could handle this is we could turn the mixed number into an improper fraction and then find common denominators. So to turn a mixed number into an improper fraction, what we do is first we multiply the denominator by the whole number. So we're doing 2 times 2. And then we add the numerator to this product. And we divide by the original denominator, which in this case is 2. And now what we're going to do after this is we're going to subtract 3/4. But now to simplify here, I just have to make sure I simplify this nicely. First I multiply, then I add. I'm doing 2 times 2 is 4, and then 4 plus 1 over 2 like this. Okay, and then minus 3/4. And now I'll write the result over here. So in this space over here, 4 plus 1 is 5, and we're over 2, and we're subtracting 3/4. And the reason why I'm making space is because I need to find common denominators if I'm going to subtract 5/2 and 3/4. And the common denominator here would be 4. So I could multiply this first fraction here by 2/2. And then we do 5 times 2 is 10, over 2 times 2 is 4, and we're subtracting 3/4. So now from here, we could close this out. We're doing 10 minus 3 over 4. So we do the subtraction, 10 minus 3 is 7, and we're over 4. But notice that 7 over 4 doesn't show up as an answer choice. So what we have to do is we have to turn 7/4 back into a mixed number. So I'm going to do that on the side here. We have 7 divided by 4, and we could say 4 goes into 7 one time. 1 times 4 is 4. We subtract and we get 3. And our remainder 3, we could write here like this in the numerator, and our denominator is going to be our original divisor, which is 4. So this tells us that our final answer here is going to be 1 3/4, and this is going to match up with choice B. Question 26, the shape below is made by joining 3 identical squares. Each square has a side length of 4 feet. What is the total area of the shape in square feet? So for this question here, it helps to know that the area of a square is equal to side times side. Okay, so when you have a square where all of the side lengths are equal to S, then all you have to do to find the area, or the space on the inside, is you do the side times the side. Okay, so side times side, but the side lengths are the same. So for this one, what I'm going to do now is draw in 2 more line segments. So I'm going to draw in a line segment like this and a line segment going across. And the reason I'm doing this is so we could see the 3 identical squares. Okay, so the squares are all exactly the same size. Now, there are some side lengths missing here, but if one of the sides of the square is 4 feet, then the length of the sides of all of the squares is 4 feet going in all directions. Okay, so that would tell us if, let's say, this space here is 4 feet, then this one over here would be 4 feet. If this vertical piece here, the one going up and down, is 4 feet, then I could say this one is 4 feet, and I could say this one over here is 4 feet. And then let's say over here going across is 4 feet, so I could say this piece is 4 feet, and this one is 4 feet. And now for the last one here, see, going up is 4 feet, so then this one over here is 4 feet. So what I want to do for this one is I'm going to find the area of one square first. Okay, and the area of one of the squares, let's say I find the area of this square over here. What I'm going to do is I'm going to do the side times side. So I'm doing 4 feet times 4 feet. And when I multiply this out, I'm doing 4 times 4 is 16. And then feet times feet gives us square feet. Okay, so that's where the square feet is coming from. Now, if you're a little bit confused, like, wait a minute, what does that mean? Well, let's say I magnify one of the squares. Okay, so I'm going to draw one of the squares over here. And what I'm going to do is I'm actually going to cut this up so that we could see where the 16 is coming from. So if it's 4 feet by 4 feet, then what I'm going to do is I'm going to cut this into fourths like this. And we could see that if I draw in these extra lines here, we could see that when we have a square that goes 4 feet across and 4 feet up, that the area, 16 square feet, represents the number of small squares on the inside. Okay, so in math, it's very important that we're able to understand what the units actually mean. So when we're talking about square feet, we're talking about how many squares cover the space. Okay, so that's the concept, that's the idea of area, is we're counting how many little squares do we need to cover a space. So if we have a 4 foot by 4 foot square, that means we need 16 little 1 by 1 squares to cover that space. Okay, but the question here, we have to be careful, is asking us for the total area. So we want the total area, and remember, there were 3 identical squares. So the total area, we could say, is equal to 3 times 16 square feet. And I'm going to abbreviate square with SQ like this. Okay, so we do 3 times 16, and that I'll do on the side, 16 times 3. We have 3 times 6 is 18. We carry the 1. 3 times 1 is 3, plus 1 is 4. So the final answer would be 48 square feet. And 48 square feet matches up with choice D. Question 27, Luna is baking full sheet cakes for each class at her school. The shaded part below shows the fraction of a bag of sugar she uses for 1 sheet cake. How many bags of sugar will Luna need to bake 14 sheet cakes? So for this question, there's a lot of information, but what we could do is just go piece by piece. And the first thing that jumps out is we have the shaded part below shows the fraction of a bag of sugar. So the shaded part shows the fraction. So let's turn this shaded diagram here into a fraction. So notice there's 1, 2, 3, 4 equal pieces, and 3 out of 4 of those pieces are shaded. So the fraction we're dealing with here is 3/4. So if we reread this sentence here with the 3/4, that'll take us to the next step. So we have that it takes 3/4 of a bag of sugar to make 1 sheet cake. Okay, so I'm just going to write that down. We have 3/4 of a bag of sugar. So 3/4 of a bag of sugar equals 1 sheet cake. Okay, or for 1 sheet cake, but I'll say that 3/4 of a bag of sugar will make 1 sheet cake. Okay, this is going to be very important because now we're asked how many bags of sugar will Luna need to bake 14 sheet cakes? Well, if it takes 3/4 of a bag of sugar for 1 sheet cake, for 14, we could multiply. Okay, so now we're going to do 3/4 times 14. Okay, so I'm going to do that over here. I'll do 14 times 3/4. And for this, when you're multiplying fractions, what you do is you multiply the numerators together and the denominators together. So since 14 is not in fraction form, I could write 14 as a fraction if I write 14 over 1. And now what we do is we do 14 times 3. So we multiply the numerators together, and then we divide by the product of the denominators. So we're doing 1 times 4 like this. Okay, so now I could do this math on the side. 14 times 3. We have 3 times 4 is 12, carry the 1. 3 times 1 is 3, plus 1 is 4. So this is going to give us, in the next line, we're going to have 42 divided by 4. And for this, we could do long division. Okay, so 42 divided by 4. We say 4 divided by 4 is 1. 1 times 4 is 4. We subtract, we get no remainder. Then we bring down the 2. 2 divided by 4 is 0. 0 times 4 is 0. We subtract 0, we get remainder 2. So this is going to be 10, and 2 is our remainder, but we divided by 4. So we get 10 and 2/4. But if we reduce 2/4, I'll do that in a different color. 2/4, we could divide, we'll make this a little neater. We could divide top and bottom by 2. And this fraction reduces to 1/2. So we could say that 10 and 2/4 is equal to 10 and a half. And this tells us that choice C is our answer. Now, one extra tip here, something we could have done. When we multiplied these two numbers over here, what we could have done is we could have reduced before we multiplied. So when we did 14 times 3/4, we are allowed to divide 14 and 4 by 2. Okay, so what I have here, 14 over 4. If I divide 14 and 4 by 2, this is the math that I'm doing in my head, that question will be giving us smaller numbers, and it'll make it easier to do the division step. Okay, so what I'm doing in my head is I'm doing 14 divided by 2 is 7, and I'm doing 4 divided by 2 is 2. So now this turns into 7 times 3 over 2, because once again, I reduced the 14 to get 7, and I reduced the 4 to get 2. So we divide the top and bottom by 2, and you are allowed to do this when you are just multiplying two numbers and one of them is a fraction. Okay, this also works if you have the product of two fractions. You're allowed to reduce any numerator with any denominator. So now we work this out and see how we're doing. 7 times 3 is 21 divided by 2. And if I do this division problem on the side, 21 divided by 2, 2 goes into 2 once. 1 times 2 is 2. We subtract. We bring down the 1. And now 1 divided by 2 is 0. 0 times 2 is 0. And we have a remainder of 1. So our remainder 1 goes up and our divisor 2 goes down. And we still get 10 and a half. Okay, so either way, choice C is our answer. Question 28, the rectangle shown has a length and width that are different sizes. How many lines of symmetry does this rectangle have? So for this question, we just look here and see that if we draw a line down the middle like this line would cut the rectangle in half. And let me just move this over a little bit so that it's more central here. Okay, so this would be one line of symmetry. We could also draw a line of symmetry going across like this. Okay, so we could draw one going this way. And I'll just make sure that this is once again going to the center. And then from here, a lot of students look at this and say, oh, there's also a line of symmetry here. And there's a line of symmetry here. But we have to be careful. This is a very, very dangerous bear trap, okay? There is not 4 lines of symmetry. A rectangle like this, where the length and width are different sizes, have exactly 2 lines of symmetry. Now, if you're not convinced that there are exactly 2 lines of symmetry, what you could do is you could draw this rectangle, but then spin it. So let's take this rectangle here and let's turn it this way. So I'm drawing it so that the diagonal line going across, we could see the diagonal going straight up and down like this. Okay, so let me just turn this a little bit more. And now watch what happens when I connect opposite corners. So when I connect this one here to this one here, like this, now I would say it's more obvious that this line is not a line of symmetry. Because if you were to take this point here and you were to fold this over the red line like this, you see how it would land over here. This would be the point opposite of the red line, but the same distance to the red line like this. Okay, but for a line to be a line of symmetry, that would mean that when you fold a point across the line of symmetry, so let's say in the first rectangle here, I fold this point here in red over the horizontal line, it would land up here in this corner. Okay, so the rectangle would fold onto itself with no overlap. So the diagonal lines are not lines of symmetry because the corner points like this would fall off of the original rectangle here, so they wouldn't count. So choice D is out, definitely choice C. Question 29, which of the following shows 0.08 written as a fraction in simplest form? So for this question, it's very tempting here to say that 0.08 is equal to 8 over 10. But choice A is a very dangerous bear trap, okay? This is not how we're going to express 0.08. 0.08 is written as 8 hundredths, okay? So over here, in terms of place value, this is the 10th place. And then next, we would have the hundredths place, okay? So the hundredths place is over here. So when we just have 0.08, this is not 8 tenths, this is 8 hundredths, which would be 8 over 100. So then we look and we see choice D. But no, choice D is another bear trap, okay? The question says to write the fraction in simplest form. So now we would have to reduce this fraction. So we are going to divide the numerator and denominator here by 4. Okay, so we're going to divide the top and bottom by 4. That is the greatest common factor of 8 and 100. 8 divided by 4 is 2. And 100 divided by 4 is 25. So choice B, 2 over 25, is our answer. Question 30, Jackson jogs 2/3 of a mile each day. How far does he jog in 5 days? So for this one here, what we could do is we could just draw out, I'm going to draw out 5 squares like this, okay? And what I'm going to do is I'm going to write 2/3 in each of these squares. And we're told here that Jackson jogs 2/3 of a mile each day. And we want to know how far does he jog in 5 days. Well, if he jogs 2/3 of a mile each day and he does this for 5 days, what we could do is we could add up 2/3 plus 2/3 plus 2/3 plus another 2/3 plus another 2/3. But this gets very tiring, especially if we were to count this for, let's say, 50 days. I don't want to write 2/3 plus 2/3 50 times. So what we do is we think, how do we replace repeated addition? Well, repeated addition is multiplication. So we could just say 2/3 times 5, or we could say 5 times 2/3. And when you multiply a whole number by a fraction, you multiply the whole number by the numerator and you keep the denominator the same. Okay, so from here, what we could do is we could say 5 times 2 over the denominator 3. And now this simplifies to 5 times 2 is 10 over 3. And for this, we could do long division. So we're going to say 3 going into 10. 3 goes into 10 3 times. 3 times 3 is 9. So we go minus 9 and we get a remainder of 1. But now the remainder of 1, we write in the numerator, and our denominator is our original divisor. So we get 3 1/3. So this tells us that Jackson in total jogs 3 1/3 miles. Choice B is our answer. Question 31, Logan is building a race car track. He uses 3 feet 7 inches of red track and 5 feet 6 inches of blue track. What is the total length of track Logan uses? So for this one, I'm just going to draw this out. So we have the red track is 3 feet 7 inches. So I'll just abbreviate feet with FT and inches with IN. And then next we're told that Logan has 5 feet 6 inches of blue track. So that I will draw in blue over here. And this is going to be a bit longer. And we have, once again, 5 feet 6 inches. And the question is, what is the total length of the track that Logan uses? Okay, the total length of track that Logan uses. So here we're going to be adding this stuff together. But when we add, we have to make sure that we are adding the like terms. So we're going to add feet with feet, and we're going to add inches with inches. Another important detail is noting that 1 foot is equal to 12 inches. So when we add this up, when we get to the end, we're going to have to do a little bit more math. So we have 3 feet plus 5 feet is going to give us 8 feet. And then when we do 7 plus 6 is 13, we have 13 inches. But the problem here is that 13 inches is more than 12 inches. So this is more than 1 foot. So we're going to have to deal with this piece over here. We're going to have to take care of 13 inches. Notice there is no answer choice that says 8 feet, 13 inches. So there's a few ways you could handle this. You could just take 13 and you could divide it by 12, because every group of 12 inches that we have 1 foot. So let's find out how many groups of 12 we have. So we do 13 divided by 12 is 1. 1 times 12 is 12. And then we subtract. 13 minus 12 is 1. So we get 1 and 1/12. So what this means, 13 inches, we could say is equal to, so I'll write this over here, 13 inches is equal to 1 and 1/12 feet. But another way to say this is we could say that 1 and 1/12 feet is 1 foot and then 1 inch, okay? Because 1/12 of a foot would be 1 inch. So this is how we would write the mixed number for feet in terms of feet and inches. Okay, so now what we could do with this information is we could rewrite this part here. So we're going to rewrite this down here as 8 feet plus we have 1 foot and then we have 1 inch. Okay, so I'm going to say 8 feet plus 1 feet plus 1 inch. So now we'll just make this a little neater. We're going to combine these two. So 8 feet plus 1 feet is equal to 9 feet. So we have 9 feet and then we have 1 inch. Okay, so 9 feet, 1 inches. Choice C is our answer. Now, one thing I want to point out is when we say 9 feet, 1 inches, that's the same thing. So I'm just going to point this out over here. So 9 feet, 1 inches. That's the same exact thing as saying 9 feet plus 1 inch. Okay, because if, let's say, well, how about we use someone's height? Let's say somebody was, I don't know, 5 feet, 3 inches tall. So someone's 5 feet, 3 inches tall. That means they're 5 feet plus another 3 inches. Okay, but we don't say, oh, I'm 5 feet plus 3 inches tall. We say 5 feet, 3 inches. And it's the same idea with mixed numbers too. Something like 1 and 1/12 is the same exact thing as saying 1 plus 1/12. Okay, so with mixed numbers, you could get rid of this plus sign and just squeeze the numbers together and write them this way. And it's a similar idea when you're talking about height or length and you're using feet and inches together. Okay, so that's why I was able to go from 8 feet plus 1 feet plus 1 inches to 9 feet, 1 inches like this. I could put the plus sign between them like this, but it's more common to express length in this form here. Choice C is our answer. Question 32, point Q is shown on the number line between 0 and 1. The number line is divided into 8 equal parts. Which fraction best represents the location of point Q? So for this one, they told us that the space between 0 and 1 is divided into 8 equal parts. So notice we're going 1, 2, 3, 4, 5, 6, 7, 8. So if I were to write fractions here, this would be 1/8, and then we would have 2/8. We have 3/8, 4/8, 5/8, 6/8, 7/8, and then the last one here at 1 would be 8/8. But 8 divided by 8 is equal to 1, so it makes sense here that we're landing at 1 when we're counting by eighths. Okay, technically over here, I could say that this is 0/8, and 0 divided by 8 is 0. So yeah, this is how we would cut up this number line. And it's because they told us the number line is divided into 8 equal parts. Okay, so this one here, once again, we're breaking this into 8 equal parts. But the question is, which fraction best represents the location of point Q? So we go to point Q and notice that this is lined up with 6/8. But then we look and we say, oh no, 6/8 is not there. My answer is not showing up. And that's because we have to reduce our fractions. Okay, so we could divide top and bottom here, the numerator and denominator, by 2. And then 6 divided by 2 is 3. 8 divided by 2 is 4. So 3/4, choice C, is our answer. Now, just know, when I wrote out this number line here like this, something like 2/8, I could divide the numerator and denominator by 2 and write this as 1/4. And then for this fraction, 4/8, I could express this as 1/2. 6/8, once again, we reduced to 3/4. And then the last part here is just equal to 1. But I like to write out my fractions on the number line unsimplified because it helps to show how we're counting to get from 0 to 1 when we break up the space between 0 and 1 into 8 equal parts. But if your teacher is requiring you to write all of your fractions simplified on your number line, then of course actually rewrite the ones that are unsimplified, like these 3 over here. Make sure that you write them in simplest form, where at point Q, once again, we're at 3/4. You could think of it this way, but then maybe write it out in simplified form. But for multiple choice, it's all about finding a pathway to the correct answer. And in this case, choice C is our answer. So now we're moving on to section 2, the free response, and there's 8 questions here. Question 33, during Autism Awareness Month, the students at Bear Creek Elementary held a cookie fundraiser. The bar graph below shows how many cookies each grade sold. What is the total number of cookies sold by grade 3, grade 4, and grade 5 during the fundraiser? And we have to show our work. So for this one, we look at the bar graph below, and what we could do is we could write the number of cookies above each of the bars. So all we have to do for that is we look to the left. So see how grade 3 is here, and it's lining up with 15. If we follow it across like this, it lands on this vertical line here at 15. So we're going to write a 15 above grade 3. And then for grade 4, notice that this bar lines up at 30. Okay, so there were 30 cookies sold by grade 4. And then finally for grade 5, this one we have to go really far, but we're going across like this. And see how if we just go straight to the left like this, we're going to be lining up with 20. Okay, so grade 5 sold 20 cookies. So now what we have to do to find the total number of cookies, we're just going to add these 3 numbers up. Okay, so we're going to do 30 plus 20 plus 15. And when we do addition like this with more than one number, just make sure you are lining up the correct place values. So we have the 1s and the 10s. So now we're doing 0 plus 0 plus 5 is 5. And then we do 3 plus 2 is 5. 5 plus 1 is 6. So this tells us here our answer. There were 65 cookies sold in total. And this is our solution to question 33. Question 34, Leo is helping organize the school art fair. He opens 7 boxes of red markers and 5 boxes of green markers. Each box of red markers has 32 markers, and each box of green markers has 48 markers. What is the total number of markers Leo opens for the art fair? And we have to show our work. So for this one, we just have to make sure that we stay organized with all of the information. So we have Leo opens 7 boxes of red markers, and they also tell us that each box of red markers has 32 markers. So this information belongs together. Well, if we think about it, if I drew this out, let's say we have the 7 boxes here. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so there's the 7 boxes of markers. And each box of markers has 32 markers. We could just take 32 and add it to itself 7 times. But there's definitely a faster way to do this. Repeated addition, we can replace with multiplication. Okay, so what we could do here is instead of just adding this number to itself 7 times, we could do 32 times 7. And now we just work this out. We have 7 times 2 is 14. We carry the 1. 3 times 7 or 7 times 3 is 21. And 21 plus 1 is 22. So there are 224 red markers. We want the total number of markers. So now next we have to find how many green markers there are. Well, we were told that there are 5 boxes of green markers, and each box of green markers has 48 markers. So once again, we could just draw it out like this and add everything up. So I could draw out 5 boxes. And we know here that there are 48 markers in each of the 5 boxes. And from here, what we could do is we could take these 48s and we could add them all together. Okay, but the faster way to do this would be to multiply 48 times 5. So let's just multiply this out. We have 48 times 5. And now we do 5 times 8 is 40. So we write our 0 and we carry the 4 from 40. And now we move to the next multiplication here. We're doing 5 times 4 is 20. 20 plus 4 is 24. So this tells us there are 240 green markers. But the question here is asking for what is the total number of markers. So now for the total is equal to, we're doing 224 plus 240. So now we add the total number of red and the total number of green markers to find how many markers altogether Leo opens for the art fair. So we do 4 plus 0 is 4, 2 plus 4 is 6, and 2 plus 2 is 4. So there are 464 markers in total that Leo opens for the art fair. Question 35, during a school trip to the zoo, students chose one of the 3 lunch options at the cafeteria. 3/7 of the students chose pizza, 2/5 chose hot dogs, and the rest chose chicken nuggets. What fraction of the students chose chicken nuggets? So for this question, this can be a little bit tricky, but the key is to visualize what's going on here so that we could find what fraction of the students chose chicken nuggets. So what I imagine is a circle, and when they tell us in the beginning that 3/7 of the students chose pizza, let's just say 3/7 is roughly, we'll say it's roughly in this neighborhood here. So let's just say that's 3/7. So 3/7 of the students chose pizza. So I'm just going to say here 3/7 is for pizza. And then next we have 2/5 chose hot dogs. Okay, so 2/5 chose hot dogs. Let's say that would be somewhere over here like this. Okay, so this represents the number of students that chose hot dogs. So the $1 million question here, though, is what fraction of the students chose chicken nuggets? Okay, so we're looking for the remaining fraction. But one thing to be mindful of is that this entire thing here makes up one whole. Okay, so what we're going to do is we're going to take 1 and we're going to subtract 3/7, and then we're going to subtract 2/5. So now from this step, the next concept that we need is we need to know how to subtract fractions from whole numbers and just fractions from each other in general. Okay, so here, 1, we're subtracting 3/7 and then 2/5. But what we have to look for is a least common multiple. So our denominators are 5 and 7. And if I start counting by 5s, notice that I get to here. So we have 5, 10, 15, 20, 25, 30, 35, 40, and so on. And if I count by 7s, I get to here, and I could see the least common multiple in both of these lists is 35. Okay, so that's the denominator that I want. Now, just know the first number 1, we could express as 1/1. And I could start counting by 1s here like this until I get to 35. But 35 is, once again, still the least common multiple, even when we have this denominator of 1 over here, because, yeah, we're not skipping by a lot. We're just counting by 1s. So eventually we'll hit 35, and that'll be the least common multiple for all of these fractions. So now what we do is we make common denominators for all of the fractions. So here, 1, I could think of 1 as 1/1, and I could multiply by 35 over 35. And this would turn the fraction into 35 over 35. So I could write 1 over here as, let me make this a little neater. We could write 1 as 35 over 35. And if we needed to check, we could say 35 divided by 35 is 1. It brings us right back to where we started. But now for the next fraction here, let's say we're looking at 3/7 next. So 3/7 over here, this one, what I'm going to do is I'm going to turn this into a fraction with denominator 35. So we're going to multiply the bottom, the denominator, by 5. So then we have to multiply the top, the numerator, by 5 as well. 3 times 5 is 15. 7 times 5 is 35. So now we have minus 15 over 35. And now for the last fraction here, the 2/5, this one I need to turn into a fraction with a denominator of 35. So on the side, I'll do 2/5 and multiply by 7 over 7. 2 times 7 is 14. 5 times 7 on bottom is 35. So we're subtracting 14 over 35. Now, with questions like this, when you're subtracting two fractions, you could just go from left to right. You go one at a time. So first, I'm going to subtract these two. So what we do first is we subtract 35 minus 15. And if that math is a little tricky to do in your head, you could always write out 35 minus 15 and do 5 minus 5 is 0. 3 minus 1 is 2. So first we get 20 over 35. And now minus, we have the 14 over 35 to do next. Okay, so we have this left. All right, so just to show here, when we subtracted these two fractions, we wound up with 20 over 35. So at this step, I'm not going to reduce because I need to have common denominators to subtract my fractions. So now next, we're doing 20 minus 14, and 20 minus 14 is 6. So this now simplifies to, we could say the final answer is equal to 6 over 35. Now here, we're not going to reduce, or we can't reduce. And how I know that reducing is not possible is I think of 6, and 6, if I factor it, is 3 times 2. And 35, if I factor it, is 5 times 7. We cannot reduce anymore, and notice there are no common factors between 6 and 35. So what fraction of the students ordered chicken nuggets? We're going to circle our answer and say 6 over 35. Question 36, the two models below are the same size and are each divided into equal parts. The shaded parts in each model show a fraction of the whole. How many more parts need to be shaded in model B so that it shows the same fraction as model A? And we have to explain how we figured out our answer. Well, for this one, there's a few ways we could go forward with this, but what we could do first is write the corresponding fraction next to each model. So if we look at model A, notice there are 1, 2, 3 equal pieces, but 2 out of 3 pieces are shaded. So what we have here is we could say that 2/3 is represented by model A. And now for model B, if we count the total number of pieces, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal pieces. So we're going to have a denominator of 12, but if we count, we have 1, 2, 3, 4, 5, 6 pieces are shaded. So what we're looking for now is how many more parts need to be shaded in model B so that it shows the same fraction as model A. And one way we could go forward with this is we could subtract these two fractions. But in order to subtract these two fractions, what we could do is find a common denominator between both of them. So if we look at, let's say the denominators right now, we have 3 and we have 12. Well, we could count by 3s, and we have 3, 6, 9, 12, 15, and the list continues by going up 3. And then if we count by 12s, we have 12, 24, 36, and so on. You could see that 12 would be our least common multiple. So that's going to be our common denominator that we want. So let's go ahead and find this now. So we have 2/3, and we are subtracting 6 over 12. But once again, the common denominator that we want is 12. So we're going to take the first fraction here, 2/3, and we're going to multiply the top and bottom by 4. And then in our next side here of our equation, we have 2 times 4 is 8 over 3 times 4 is 12. And we're subtracting 6 over 12. So now we have common denominators. So at this step, we can combine these two. So we could do 8 minus 6 over 12, and this reduces to 2 12ths, okay? Or this simplifies to 2 12ths. Our fraction is not in simplest form, but we have to think about how many more parts need to be shaded in model B. Well, we have to shade 2 12ths. So that means we would have to shade 2 more parts, okay? So we'd have to shade 1, and we'd have to shade another one like this. And you could see that now, if we look at the new fraction that's shaded, we have 8 12ths. And if we reduce 8 12ths, divide top and bottom by 4, we get 2/3. So now we could just write out our final answer here. So we're going to say we need to shade 2 more parts in model B. So I'm just going to write that out here. We need to shade 2 more parts in model B. So we need to shade 2 more parts in model B. And now we have to explain. So we have to write another sentence. How do we know that we need to shade 2 more parts? So really what we're doing is just summarizing the evidence that we gathered here. Okay, so we need to shade 2 more parts in model B. And how do we know? Well, we could say the way we determined our answer was we subtracted the fraction represented by model A and the fraction represented by model B, and the difference, 2/12, told us that we need to shade 2 of those parts in model B. Question 37, the line plot shows the lengths of green iguanas at the zoo. How many green iguanas are exactly 5 3/8 feet long, and what is the total length of all the green iguanas that are 5 3/8 feet long? And we have to show our work. So for the first part of this question, we want to know how many green iguanas are exactly 5 3/8 feet long. So we look to the line plot and we find 5 3/8, and here it is. And then we look above at this column and count the number of X's. So there are 1, 2, 3, 4, 5 X's here. And that tells us that there are 5 green iguanas that are 5 3/8 feet long. Okay, so we could say there are 5 green iguanas that are 5 3/8 feet long. So next we're going to find what is the total length of all the green iguanas that are 5 3/8 feet long. Well, there are 5 green iguanas that are exactly 5 3/8 feet long. So what we could do is we could do 5 3/8 plus 5 3/8, and we could add 5 3/8 to itself 5 times. So we can add all of these mixed numbers together, but there is a faster way. Repeated addition we could replace with multiplication. So this is the same thing as 5 times 5 3/8. And when you multiply a whole number by a mixed number, what you want to do is you want to turn the mixed number into an improper fraction. So on the side here, I'm going to take 5 3/8 and turn this into an improper fraction. So we do 8 times 5, and then we add the numerator. Okay, so we're going to add 3 to the product of 8 and 5. And we're dividing by the original denominator is 8. So now we multiply before we add. We do 8 times 5 is 40, and then we have 40 plus 3 over 8. So our mixed number as an improper fraction is equal to 43 over 8. So we could say next that this product here, so over here, we're just going to draw it over here. We're going to say this is equal to, we have 5 times 43 over 8. I'll just make this a little bit neater. So 5 times 43 over 8. And now for this part, when you multiply a whole number by an improper fraction or any fraction, you can multiply the whole number to the numerator. So now on the side here, I'm just going to work this out. We have 43 times 5. And we do 5 times 3 is 15. We carry the 1. And then 5 times 4 is 20. 20 plus 1 is 21. So this will work out to, we could say, 215 over 8. So once again, the product of 5 and 43 goes in the numerator, and the denominator stays the same here. But let's say we had to write our answer as a mixed number. Well, if we had to write our answer as a mixed number, then we could do the long division on the side. So I'm going to do 215 divided by 8. And we'll say 21 divided by 8 is 2. And we do 2 times 8 is 16. And we subtract. The difference here, 21 minus 16, is equal to 5. And then we bring down the 5 here. And now 8 goes into 55 6 times. If we did 8 times 7, that would be 56, which goes too far. So we could get as close as 8 times 6. And 8 times 6 is 48. We subtract, and we have a remainder of 7. So our remainder of 7, we could go over 8 like this. And this tells us our final answer is, we could say 215 over 8, or we could say 26 and 7/8. But let's write out our answer more formally. What is the total length? I'm just going to write over here. We're going to say the total length is equal to 26 and 7/8 feet. Question 38, books have been arranged for a book fair. There are 14 shelves of books with 10 books on each shelf. When the fair ends, the books are packed into boxes. If each box holds exactly 8 books, what is the fewest number of boxes needed to pack all of the books? And we have to explain how we know our answer is correct. So for this one, first we should find the total number of books. Okay, so we're going to find the total number of books. And for this one, we have to reread the question and look for the important information. Just know with word problems, sometimes you have to read the questions more than one time to really understand what's happening. But for the total number of books, that information is coming from here. There are 14 shelves of books with 10 books on each shelf. So this tells us there are 14 times 10 or 140 books. When you multiply any number by 10, any whole number, you just add a 0 at the end, and that's a nice shortcut to multiply by 10. So once again, there are 140 books in total. But now the next part of the question, we're told that when the fair ends, the books are packed into boxes and each box holds exactly 8 books. And the actual question here is, what is the fewest number of boxes? So I'll put this in another color. What is the fewest number of boxes needed to pack all of the books? So for the next step here, what we're going to do is we're going to divide. We're going to take the 140 books in total and we're grouping them into boxes, and each box holds 8 books. So we're taking the 140 total books and making groups of 8. So we divide. 14 divided by 8 is 1. 1 times 8 is 8. We subtract and we get 6 left over. We bring down the 0 and now we do 60 divided by 8 is going to give us 7. 7 times 8 is 56. When we subtract, we have a remainder of 4. So we have 17, and this time I'm going to write remainder 4 like this. I could say 17 and 4/8, but I'm going to write remainder 4. Because the idea is, if you think about this, we have 4 books left over, but what is the fewest number of boxes needed to pack all of the books? Well, in this case, we're going to need 18 boxes, because if you think about it, if this is how many boxes we have 17, but then we have remainder 4. What that tells us, if we were to think about this, carefully, 17 remainder 4 means 17 and 4/8. But 4/8 is equal to a half. So we would need 17 and a half boxes. But if you're packing up books, you can't have half of a box. Okay, even if this fraction was really small, like let's say 1/8, we would still need the 18th box because we would need space for that extra book. Okay, so we can't have part of a box. We could only have a whole number of boxes. So we're going to need 18 boxes. So just to summarize here, we're just writing down all the work that we did. We mentioned that there are 140 books in total, and that when we divided, we had a remainder of 4. So that's why we need the 18th box for the 4 leftover books. Question 39, Liam is making smoothies for his friends based on the information below. He has 6 liters of juice. He uses 2/3 of a liter of juice for each smoothie, and he makes 7 smoothies. How many liters of juice does Liam have left after making all the smoothies? And we have to show our work. So this is a type of question where, once again, you have to read it more than once to really understand what's happening here. So what we have is Liam has 6 liters of juice. So this jumps out at me right away as being the total. Okay, so this tells us the total liters that Liam is working with. And then next, we're told that he uses 2/3 of a liter of juice for each smoothie, and he makes 7 smoothies. So the stuff that I underlined in red, and I'll just make this a little bit neater. So we have this stuff here in red belongs together to start the question. Okay, so each smoothie uses 2/3 of a liter of juice, and he makes 7 smoothies. So we could do 7 times 2/3, and this will tell us how many liters that Liam needs to make the smoothies for his friends. Okay, so we multiply these two together. And we work this out. We're going to multiply the whole number by the numerator 2. So we're doing 7 times 2 is 14, and then we have 14 over 3 like this. And this tells us, once again, Liam needs this many liters. Okay, so Liam needs this many liters of juice to make the smoothie for his friends, or all the smoothies for his friends. But now the question is, how many liters of juice does Liam have left over? Okay, so how many liters of juice does Liam have left after making all the smoothies? So what we're going to do is we're going to take the total here, 6, and we're going to subtract the amount of liters that Liam needs to make the smoothies for all his friends. So we're going to subtract 14 over 3. But this is a situation where we need to find common denominators, because technically 6 we could write as 6 over 1, because 6 divided by 1 is equal to 6. And we need to find a common denominator between 1 and 3. Well, we could multiply this first number here by 3 over 3. And that's going to give us the common denominator of 3. So we do 3 times 6 is 18 over 3 times 1 is 3, and then minus 14 over 3. And now we simplify. We could do 18 minus 14 over 3, and we're left with 4/3. So this, if we want, we can write 4/3 as a mixed number. We could say 4 divided by 3 is 1. 1 times 3 is 3, and we subtract, and we have a remainder of 1. So the remainder of 1 goes here, and our original divisor is our denominator. So we could say that Liam has 1 1/3 liters of juice left after making all the smoothies. Now, one thing I want to point out in terms of a test-taking strategy, if the question doesn't say to write your answer as a mixed number, it's appropriate for you to stop here and say Liam has 4/3 of a liter of juice left after making all the smoothies. Because if you do extra work that's not required of you, and you do that extra work wrong, that's an annoying way to lose points on a test. So when the question says, hey, just how many liters, and they don't say write your answer as a mixed number, then you're allowed to stop at this step. Okay. And one other thing to point out, the abbreviation for liters, you could just put a capital L like this. And this is just a way we could write out our final answer. Liam has 1 1/3 liters of juice left after making all the smoothies. Question 40, a drone was programmed to fly straight up to a height of 1,088 feet to take pictures of the forest below. During a science project, the drone repeated the same flight 4 times in one day. The area model shown below represents one way to find the total height the drone climbed that day. And for the first part of the question, we're looking for what are the missing values for A, B, and C in the area model, and we have to show our work. And then next, we'll have to find what is the total height in feet the drone climbed after 4 flights, and we also have to show our work for this part. So for the first part, we're looking for the missing values for A, B, and C, and we're using the area model. And since we're dealing with rectangles here, we should know that the area of a rectangle, so the area of a rectangle is equal to the length times the width. Okay, we multiply the length times the width. So if we want to find the value of A, notice that A is a part of this rectangle here. This is the space on the inside. So A is part of this rectangle. And we would just multiply the length times the width. So we could say A is equal to 1,000 times 4. And for this, we could do long multiplication like this. We could do 1,000 times 4 and do 4 times 0 is 0, 4 times 0 is 0, 4 times 0 is still 0, and 4 times 1 is 4. And this gives us 4,000. Or if you want to do this math in your head, that's fine. Just notice the pattern here. So if we do 4 times 1, we get 4. If we do 4 times 10, we get 40. So when we do 4 times 100, see how there's 2 zeros at the end here? We do 4 times 1, and then we just throw on 2 zeros. So 4 times 1,000, we do 4 times 1, and then throw on 3 zeros at the end. So that's the way you do it in your head. But if you have to do long multiplication, then do the long multiplication. So now for the next one here, so I'm going to highlight this one in red. So for this rectangle, this one, we have, I'll write it off to the side like this. We have 4, and then 320, and then B. Okay, we could assume here that all of these little straight line segments going up like this, up and down vertically, are the same length. They're all 4 units long. So we would have here, this tells us that 4 times B is equal to 320. But to find the value of B, we have to know the relationship here between multiplication and division. I used this example before, but I'll say it again. If I have something like, let's say I do 6 times 5 equals 30, I can say that 30 divided by 6 is equal to 5. So if I have 4 times B is equal to 320, I could say that B is equal to 320 divided by 4. And for this, the math that I'm doing in my head, I'm doing 32 divided by 4 is equal to 8. And that allows us to say after this that B is equal to 8. And then I just throw on that extra 0 so I could say 80. Okay, the same way we do 4 times 1 is 4, 4 times 10 is 40. Having that extra 0 just throws an extra 0 on after we do the division. If we had to, though, of course, we could do long division here to get 80, but it's nice to look for patterns in math to get our answer that way. Okay, so I'll write out our values for A over here like this. So we have 4,000 is our value for A. Our value for B was equal to 80. And now our value for C, we'll do this one here in purple. We're going to look at one last rectangle. So we have this rectangle here is for C, and we have 4 and then 8 going across. I'm not drawing this to scale necessarily. This is just to help us, visualize what's going on. So C is going to be equal to 4 times 8. We're using the area model. So we use the formula for the area of a rectangle. We're doing length times width. So if we do 4 times 8, we get 32. And this gives us the value here for C. So now we're ready to answer the second part of the question. We want to know what is the total height in feet the drone climbed after 4 flights. And for this, we found A, B, and C. And B was equal to 80. So if I write this in place over here, notice that we have 1,000 plus 80 plus 8 going across like this, which makes 1,088, which is the distance or the height that the drone flies up to take pictures of the forest. But the drone did 4 flights. So really what this area model is doing for us is it's doing the product of 1,088 and 4. So when we want to find the total height, all we have to do now is just add these values up on the inside. Okay, we're going to be adding up these values here. We're going to add A, we're going to add 320, and we're going to add C like this. Okay, just be careful here. Don't do 4,000 plus 80 plus 32. It's very tempting to want to just add A, B, and C. But remember from before, the B value here was on the outside. So we're not going to add the B value. We're going to add the 320 because that's on the inside where the area belongs in an area model. So now we just add this up. We're doing A is 4,000. And then we're going to add 320. And then we add C. C is equal to 32. Okay, so we add those values up. 0 plus 0 plus 2 is equal to 2. We have 0 plus 2 is 2. And then 2 plus 3 is 5. And then 0 plus 3 is 3. And the 4 just carries down like this. So the total height, we could say, the total height, we're going to say is 4,352 feet. And this is our solution to the last question. Now, one thing I want to point out, one way to check our work is we could just multiply here. So I'm going to check our work off to the side. We could just go ahead and multiply 1,088 and we multiply this number by 4 because they told us that the drone made this flight up 4 times. So if we work this out, we should get 4,352 and then that'll tell us our answer is 100% correct. So 4 times 8 gives us 32 and we carry the 3 here. So then we have 4 times 8 is 32. 32 plus 3 is 35. We carry the 3. And then we do 4 times 0 is 0. And 0 plus 3 is 3. And then finally 4 times 1 is 4. And notice we get the exact same answer. So the total height is 4,352 feet.